Good morning, Year 10. Hopefully it's Monday morning and you're starting to get used to this online learning. Anyway, this is yet another video I've been making, first for Year 10, and basically to stay in touch with you and see how you're getting on. Last week I gave you some work on moments, and some of you already started doing lessons, some of you a little bit behind. But anyway, what I was aiming at was this lot here is basically looking at levers and gears. I need to explain how they transmit rotational forces. And then what your spec asks you to do is calculate the moment of force, including the units, draw a diagram showing the moment of force, and then we need to state the principal moments for a balanced object. And the higher end, going grade 7 above, really is performing calculations which include rearrangement of the moment equation. Now, we had done this little bit already, and levers and gears I've shown before. Sorry, levers did, but not gears. And we basically saw how you calculate a moment, but some of you had not done calculations yet. I set that work last week. So some of you have been playing around with this. Now, one group I shown to, and one group had not shown, was this software, which is really, really cool. I'm going to put a link in Edmodo for you. It's called PHET, comes to University of Colorado. And simply, if you go in here on this link, you can go straight in. And it's really good to do because you've got some quizzes, etc. You've got an introduction here. But the one you really like is going to be a game. We all like games, don't we? I would advise you to start off at level 2 and then go into level 3 and possibly into level 4. And what these do here is basically you have to balance. For example, I know here the anti-clockwise moments, when you go to clockwise moments to make this balance, and here's the pivot point. So if I know this one is making it turn around anti-clockwise, which would be 12 times 1, which would be 12, I then know this one must be 1, 2, 3, 4. Suddenly it balances. And the reason why is 3 times 1, 2, 3, sorry, 1, 2, 3, 4 is 12 Newton meters. Well, if I had really 30, because that's 3 times 10, that'd be 30 Newton meters. Will be the same as then when you've got your one distance here. Therefore, that 3 multiplied by that distance is the same as 12 multiplied by this distance. Technically, you should convert that into newtons to make that 30 times 4 makes 120. And technically, that should be 10 times 12, which is 120 times 1, which is 120. You can go away in this case. It's just because it balances out an equation. Anyway, have a go playing around with that. It's a nice bit of software. The link you'll find available. And then you're going to find calculations like this. Now, I'm going to quickly look at the first one, calculate weight C, and I'm going to go a bit of writing here. So I'm going for this one here. So on these ones, what you always do is showing the layout to the examiner in the questions. And what I always do is I do the anti-clockwise moments is equal to the clockwise moments. So example, I know C is going to turn it around anti-clockwise. These two are going to turn it around clockwise around this pivot point here. So in other words, then you're going to have C multiplied by the perpendicular distance, which is going to be 0.25, is then going to equal to this one here, which is going to be 2 parts, because you've got the 4 multiplied by the perpendicular distance is 0.15. And then what you're going to do is it's going to be 1 multiplied by 0.4, which is that 1 Newton multiplied by the perpendicular distance. And then it comes down to good old mass. 0.25 C, and we all know 4 times 0.15 is 0.6. And then 1 times 0.4 is going to be 0.4. Therefore, 0.25 C is then equal to 1.0. Therefore, C is going to be 1 divided by 0.25, which then is equal to your 4 newtons. And that's the way I like to lay it out. You always write down anti-clockwise moments equals clockwise moments, then show all your working, And look, we've always said this: formula, working, answer, units. There's your formula, here's your working, there's your answer, and there's going to be your units just there. Okay, now going through book ones, I think what I'm going to do now is I'm going to upload all the answers to your book for the forces section, and they'll be included in this post in Edmodo. But this one I've seen it come up a few times is a laptop. Now laptops, which I'm actually using at the present moment, you've got a lid and the pivot point is just here. And this question states, a student finds that the minimum force required to lift the lid of a laptop is 6.4 newtons in this figure here. You can just about see that 6.4 there. Calculate the moment of the force that opens the computer. What you do is you write down your moment then. It's simply going to be force multiplied by your perpendicular distance, and it's dead easy. You then take 6.4 and then you multiply it, but this is going to be the perpendicular distance. This perpendicular distance is 90 degrees to that, which is going to be 0.25. And then when you put those into your calculator, you get 1.6 Newton meters. Again, here's your formula, there's your working, here's your answer, and here's your units. But again, you're going to get little things like this appear to explain why the minimum force required to close the computer lid is likely to be less than 6.4. And this here, really, to be honest, that's about grade 5. Yeah, this part of the question is grade 5 and beyond, probably like the grade 7-ish. And the reason why comes up here, okay? And it all comes as an idea, and I probably didn't do this in red, is you've got to remember there's actually a weight of this laptop here. And like we look at ready, we looked at the center of mass, the weight of this, in fact, is going to be acting down like that, and there's going to be your weight. When you think about it, that one is making it go clockwise about the pivot. This one here, okay, is then going to take it the other way, going over here. So when you're putting the force here, explain why the minimum force required to close a computer is likely to be less than 6.4. When you're actually closing the computer, this one, okay, you're going to push down here. So now you're not lifting up, you're now pushing it down that way to close the lid. Won't the weight as well act in the clockwise direction to make it close? So these make you think a little bit, is why then it's harder to open the lid. When you close the lid, it's easier because as you push down, this one's acting in the clockwise direction as well and helps you close it. Anyway, I'm going to put all these onto onto Edmodo, or the answers, but I thought I'd show you that one. The last bit we're not done is all about these, and these are quite freaky. This is all due now about all about gears, or moment and gears. So here, I find this quite freaky, these. Here you've got 3 gears, and they're rotating all about the center point just here. Okay, and as they rotate round, you might notice, see this one is turning the fastest, and this one's turning medium speed, and that's turning the slowest. And these are all about, literally, they multiply the turning effect. This one's really freaky. You've got an outside gear, you've got 1, 2, 3, 4 gears turning inside. I actually include this because it looks quite freaky actually. But again, you can see this one is turning the fastest, and then they slowly, well, that's going the fastest, and they slow down to this one's going the slowest here. Anyway, you got this in your book, and I thought I'd put this down to help you see it, is in your book, they call that distance there a radius r. And this one is going to be 2r. And the reason why it's 2r, because that's got 24 teeth and that's got 12 teeth. Therefore, it's got double the number of teeth. Isn't the radius going to be as big? But as they turn, you've got this one has got a force acting up here, which is F, and that is turning down there, which is going to be force F. So you think about it, the turning forces for this one is going to be FR, but this one here is going to be F2R. Therefore, if you really think about it, this one has got double the turning effect than that one, because you've got this 2R comes in. And this is why we use gears, because as you turn this around here, this one, okay, they've got the same force turning them, but this one has a much bigger turning effect than that one. So basically, you're like multiplying the turning effect, making it bigger. And that's the whole idea behind gears. We use gears, you might see in canals or opening up locks, and also using in cars. I'm using them on bicycles, which I do passionately love my bicycle. And bicycle is, yeah, what you can do is you can make the actual turning effect bigger so you go faster. But then this one here, you got the gears, and you can change a gear on your bike. Okay, you've got a chain connects them, but it's the same principle, meshing the whole lot together. So what I've done then is I've quickly gone through the last little bits that were on here, and get rid of that, ding, ding, which is basically doing these calculations here and doing a little bit in gears. Anyway, I'm going to make a few of these videos, and hope you enjoyed that, and hope you're all well at home, and I'll make another video soon. Bye for now.